Welcome to lesson 1.3. Today we're going to talk about measurements. Anytime you have a measurement, you need to have two parts to that measurement. You need to have a number and some type of unit. There are standard units of measure. The English system is used in the United States and two other countries in the world. The metric system is used in the rest of the world. The metric system kind of has a subdivided category called the SI system. It differs just a little bit from the metric system, but its units are actually derived from that metric system, and the SI system is what is used in science. So let's look at the fundamental units of the SI system. The two differences between the straight metric system and the SI system are mass, what mass is measured in. In the straight metric system, the base unit is gram, but in the SI system, we use kilogram because gram is such a small unit. The other difference between the metric system and the SI system is temperature. Temperature is measured in Kelvin in the SI and measured in Celsius in the metric system because Kelvin is actually a scientific definition of temperature. So you'll notice there are other fundamental SI units, and fundamental basically means this is as low as it goes. You cannot pull any lower than this. You can't. These are like prime numbers in math. These are the base. Anything else, any other measurements are derived from these units and called derived units. What we use in chemistry is, we use mass, we'll use length. Occasionally we'll use time, probably not in 114, but if you took Chem 2, you would use time. Temperature we'll definitely use in chemistry, and mole most definitely. We don't often use ampere or candela in chemistry, but there are some experiments that call for that. With the SI system or with the metric system, we can modify the base unit by adding a prefix, and there are lots of prefixes listed here. The blue ones are actually the ones used most often in, I would say, in any of the world, but the smaller ones we use in chemistry a lot: nano, micro, milli, centi, deci. Sometimes we'll even go to pico. Kilo we use some in chemistry. Mega, giga, and tera, you've probably seen those most in the computer industry. But please note the exponential notation on those and what they actually mean. The line is where you would put the base unit, so gram would be the base unit in mass, meter would be the base unit in distance, and so on. With metric units, as American students, it's hard for us to understand what the metric measurements really mean. If I tell you something's a foot long, generally you can picture that if you are, an American. But if I tell you something's a meter long, you don't necessarily know what that means. And so here are just some common examples. If a dime is about a millimeter thick, a quarter is about 2.5 centimeters in diameter, and average height of an adult man is about 1.8 meters. For mass, I think with length we can kind of get it because we've used rulers. Mass, we haven't had a whole lot of practice with balances, but a nickel has a mass of about 5 grams. 5 cents, 5 grams. A 120-pound person has a mass of about 55 kilograms. And with volume, we're starting to see a lot more labels. In fact, I think most labels I see nowadays, they have both the English unit and the metric unit. So a 12-ounce can of soda is about 360 mils. You do see volume sometimes in metric if you buy a 1 liter or a 2-liter bottle of soda or water or whatever. Now, volume, you do have to be careful with volume because volume is what you call a derived unit, and volume means basically length times width times height. And so if we were to look at this cube, each of these cubes is 1 centimeter on a side. So the volume of the cube is 1 cubic centimeter or 1 milliliter. It's important for you to know that those two are equivalent. Now, if we take 100 of those cubes and put them together, then we get a cubic decimeter or a liter, and then 100 of those put together gives us a cubic meter. So volume, remember, is cubed, and so you do have to be careful. We'll see some conversions where we look at that later. To measure liquid in the lab, you'll see different types of measuring devices. You often see a 100 mil grad cylinder because that's a very common measuring device. Some more specified measuring devices are pipettes, burettes, and flask. So a burette, notice this graduated cylinder goes from 0 to 100. A burette is backwards because a burette is actually a to deliver device. And so once you read the initial volume, you read the final volume, the subtraction gives you how much was added. This pipette and this volumetric flask are different types of device in the fact that they only measure one specific volume. Since this is a 25 mil pipette, the only volume you can measure with it is 25 mils. Since this is a 250 mil volumetric flask, the only volume you could say with certainty is 250 mils. They make flask and pipettes that deliver different volumes specifically. You can also get a graduated pipette, which it won't have this little widened part in the middle, but it would be very similar to this where it would have graduations on it. Mass is it is measured in kilograms in the SI system and grams in the metric system, but mass kind of has an odd definition because mass is tied to something called inertia, and so the definition of mass is actually a measure of the resistance of an object to its change in the state of motion. Mass is the same regardless of where you are in the universe. You will always have the same mass. Weight is actually a measure of the force exerted by gravity on you or any other object. So on Earth, if you weighed 600 pounds, and notice I use an English unit there because you're more familiar with it. On the moon, you would only weigh 100 pounds. But on Earth, if you weighed 600 kilograms, on the moon, you would still weigh 600 kilograms because mass does not change based on your gravitational attraction. This is kind of an interesting question, and I encourage you to stop and ponder this for a while because you really don't know, or you're probably not aware how much you use units every day. So I encourage you to stop on this and ponder. Next lesson, we're going to talk about significant figures and uncertainty in measurements.